Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and it's our second video estimating the area under a curve. So, just to remind our prior learning before we get going, you need to be really good at calculating the area of a rectangle, triangle and trapezium, because we're going to need those. And in the last particular lesson, what we did is we were told to draw a triangle or rectangle or trapezium to estimate the area under a curve. So here's two examples that we may have had in the last lesson, and we may have used a triangle to estimate the area underneath those curves. Hopefully you can see in this first case on the left, the triangle is actually a fairly decent approximation of the area under the curve, because this arc here is quite close to the curve. But in this second example on the right hand side, the triangle isn't that great an estimation in this case, because you can see the curve is quite far above the arc here, or the hypotenuse of the triangle. So in this lesson we're going to try and think of ways to make a more accurate estimate for the area under a curve using polygons. So a way to do that would be to use more shapes. So let me try and show you how this works. Here's a curve, and as I said in the last lesson we just straight drew a triangle and made that our best guess. What if, however, we split the shape into two polygons, and for example we did a triangle between 1 and 3 and we did a trapezium between x's 3 and x's 6? Hopefully you can see that would be a much better estimate. And we can make it better still by using more polygons. So why don't we think of drawing a triangle maybe between 0 and 2, a trapezium between x's 2 and x's 4, and a second trapezium between x's 4 and x's 6. And we could even get better if we divided it up into 6 polygons: a triangle between 0 and 1, a trapezium between 1 and 2, a trapezium between 2 and 3, a trapezium between 3 and 4, another trapezium between 4 and 5, and lastly a last trapezium between x's 5 and x's 6. As we use more polygons, we get ourselves a better approximation for the area underneath the curve. And this leads us to the trapezium rule, which we're going to use to do this. So the trapezium rule is basically what I've just said. All it is it says that you can use trapeziums or trapezia of equal widths to approximate the area under a curve, and that's known as the trapezium rule. So if we use these types of polygons, most of them are trapezia, but the first one may be a triangle, or you may have a triangle involved, but often you have several trapezia. So we are often told what strips to use or how wide to make the trapezia in the question already, and that's the type of questions we're going to practice in this lesson. So let's take a look at a question. Here's the first one. Pause and have a go. So we've got a velocity time graph of a car, and we're asked to find an estimate for the distance travelled by the car in the first 3 seconds, and we're told some key piece of information. Use 3 strips of equal width. Is your answer an overestimate or underestimate, and why? So we are trying to work out the distance for the first 3 seconds, so that's between here and here, and we're asked to use 3 equal strips. So we'll have a strip at time is 1, a strip at time is 2, and a strip at time is 3. And we're going to use this trapezium rule. So we're going to mark our point there, mark a point there, and mark a point there. And we're going to draw in triangles and trapezia to fit. So the first one is just a triangle. The second one is going to be a trapezium. And the third one is also going to be a trapezium. And we're going to work out the areas of these 3, add them together. That's our estimate for the distance. So making the picture look a bit prettier, it would look something like this. I'm going to call this shape 1, this shape 2, this shape 3. So the area of shape 1 is going to be base multiplied by height divided by 2. The base is 1, the height is 1, so it's going to be 1 multiplied by 1 over 2, which gives us a half, 0.5. For here we've got a trapezium, so the area of a trapezium, remember, is A add B multiplied by H divided by 2. where A and B are the parallel sides, so that's going to be A, that's going to be B, that's going to be my H. So in this particular case, it's going to be 1 add 3 multiplied by the distance apart of 1 and divided by 2. 1 add 3 is 4, 4 times 1 is 1, so it's 4, and 4 divided by 2 is equal to 2. And for the third one, the area is another trapezium, so it's going to be A add B multiplied by H over 2. We've got a different A and B here. This one's A in this case, and this one's B. So A is 3 and B is 7. So this is going to be 3 add 7 multiplied by the distance apart of 1 divided by 2. So that's going to give us 10 on top divided by 2, which is 5. Now, it didn't ask us to work out areas as such. It said, what is the distance travelled? So an estimate for the distance travelled is going to be the sum of these areas. So 0.5 add 2 add 5. And when we do that, we're going to get ourselves 7.5. Because the speed is in meters per second and the time is in seconds, the unit of distance here is going to be meters. And lastly, it said, is this an overestimate or underestimate, and why? Well, hopefully you can see that these chords are above the curve, therefore this is an overestimate. So we'll write that at the end. Okay, next question. Pause and have a go. So the velocity of a rocket is shown on the graph below. Using 4 strips of equal width, estimate the distance travelled by the rocket between 1 and 5 seconds. So 1 second is here and 5 seconds is here, and we need to work out the distance travelled. So we're going to draw ourselves, it says we use 4 strips, so we're going to use 4 trapezia, and it would look something like this. Okay? And we just need to calculate the area of each of these, sum them together, and that will give us an estimate for the distance. So for number 1, remember the area of a trapezium, I'll always write here, is A add B multiplied by the perpendicular, the height that A and B are apart, divided by 2. So in this particular case here, this point looks 1 up and this point looks 3 up. So the area of 1 is going to be 1 add 3. They're 1 apart, so multiplied by 1 divided by 2. And that area therefore gives us 2. What about for number 2? This distance here is 3 and this distance here is 7. So the area is going to be 3 add 7 multiplied by 1 all over 2, and that gives us 5. What about the third one? Well, the third one here, this is 7 and this is 15 high, so this one here is going to be 7 add 15 multiplied by 1 all over 2, and that gives us 11. And the last area, area 4, well, this is 15 and this is 30, so the area here is going to be 15 add 30 multiplied by 1 all over 2. So the area in this particular case is going to be equal to 22.5. So an estimate for the distance therefore is the sum of these, which is going to be 2 add 5 add 11 add 22.5, and that gives us in total 40.5, and the unit here will be meters, and we're done. Next question, pause the video and have a go. So we're given the velocity of a parachutist after leaving a plane. We're asked to find an estimate for the distance travelled in the first 10 seconds. Use 5 equal strips. So the first 10 seconds is from here to here. If we're using 5 equal strips, each strip must be 2 wide. 10 divided by 5 gives us 2. So this is the first strip here. This would be the second. This would be the third. This would be the fourth. This would be the fifth. And we get ourselves something that looks like the following: a triangle and 4 trapezia. So all we've got to do is work out the areas of each of these 5 shapes, add them together, and that gives us an estimate for the distance. So for shape 1, the area is base multiplied by height divided by 2, and the base is 2 and the height appears to be, in this particular case, 26. So it's going to be 2 multiplied by 26 over 2, which gives us 26. For the second one, this is a trapezium, so it's A add B multiplied by H divided by 2. So this height here is 26. We're adding to it this height here, which looks like it's 39. We're multiplying by the distance apart, which is 2, and then we're dividing by 2. In effect, this multiplying by 2 and dividing by 2 cancel each other out, and we're effectively just adding these, and we'd get 65. The third one, the area is the area of a trapezium again. It's going to be 39 add 46. So it's going to be 39 add 46 multiplied by 2 and divided by 2. And when we do that, we're going to get ourselves 85. And we continue in the same vein. So for the fourth one, we're getting ourselves 46 add 50 multiplied by 2 and divided by 2, and that gives us the answer 96. And the last one is going to be, the area is going to be here 50 add 52 multiplied by 2 and divided by 2, which actually gives us 102. So to work out the distance is going to be the sum of these. So just to get the calculator out to do it quickly, it's going to be 26 add 65 add 85 add 96 add 102, and our distance here is 374, and the unit is going to be meters. And we're done. Next question, pause the video and have a go. So again, we've got the velocity of an object over 12 seconds is shown, and we are asked, using 4 strips of equal width, estimate the distance between 3 and 11 seconds that the object travelled. So let's mark out 3 to 11 seconds here, and that is 8 wide. So each strip's going to be 2, right? So we're going to draw in our strips, 1, 2 across here, another 2 across, another 2 across, and another 2 across, like this. And neaten it up, it would look something like that. And our objective is simply to calculate the areas of these 4 trapezia, add them together for our estimate of the distance. So remember, the area of a trapezium is A add B multiplied by H over 2. So let's do it for number 1. The area here, well, this here looks like it's 4.4 high, so it's 4.4 add 6.4 multiplied by 2 apart and divided by 2. So when we do that, we get ourselves 10.8. The second one, well, our area here is, well, we know this is 6.4, and this here looks like it's 7.6, so it's going to be 6.4 add 7.6 multiplied by 2 and divided by 2. So in this particular case, we're going to get ourselves 14, and we continue this for 3 and 4. The area for 3, remember that's 7.6 add 8 times 2 divided by 2, and we get ourselves 15.6 here. And for the last one, for our area here, our A is 8, we're adding to it 7.6, we're multiplying by 2 and we're dividing by 2, and that again is going to be 15.6. So when we add these together, this will give us an estimate for the distance. So calculator out, 10.8 add 14 add 15.6 add 15.6, and we get ourselves 56. And because we've got a velocity meters per second and time in seconds, this is going to give us our distance unit in meters. So our estimate is 56 meters and we're done. And that's it for this particular video. Thanks for watching.